First off, I want to thank everybody for coming out and being a part of this, and again, spending your pre-lunch session with me. I'm sure all that's going to be on your mind is application development pipelines and not lunch, so I appreciate it. To first tell you a little bit about myself, my name is Jeff Worford. I am a DevOps engineer at KEYSYS Consulting. Just a few little tidbits about myself. I love Mexican food. I actually teach coding to middle schoolers in my spare time, which is fun. And I have a new addition to the family, so I don't sleep anymore. So if I fall asleep up here, anybody with kids understands, right? Multiple different languages. I do Node.js, Java, Golang, quite a few different ones. No, it's all HTML. Again, I work at KEYSYS now. I've been in IT for about 18 years, and I started off in network engineering. That was kind of my start. And then from network engineering, I switched over to system administration. Did that for a while, and then switched into development. Development was kind of a hobby for me. I never really thought I would do it as a career. Just something I did for fun, but I really loved it. So those things kind of meshed together and became what is now really DevOps. I was able to kind of use those and mesh them together into doing what I do now. So I've been at KEYSYS for a little under a year now, and then our DevOps practice kind of started all before I was there. So I just kind of got inundated into the way they were doing things there. So a little bit about KEYSYS real quick. KEYSYS Consulting, again, we do custom software development. We are a company of 26 people right now, majority developers. We just celebrated our 10-year anniversary end of last year. We've been doing DevOps again since 2014. Our customer base basically spans between small, applitions all the way to enterprise. So the thing that gives us a kind of unique perspective on DevOps is that things are different based on customers. Different customers have different needs. So if you have just a single website that you're deploying, or you have an enterprise system that is geo-distributed against multiple servers, things are going to be different. So we're basically set up different pipelines for different customers. We have our own internal in-house stuff that we do for automated deployment. So it kind of gives us a kind of unique perspective on all of that. So a few years ago, again, before I started, KEYSYS made the transition of going from a waterfall methodology for software development into Agile. So basically we are split into 3 teams. All 3 teams work on 1 week sprints, and those sprints end with a showcase to the customer every week. So what we're always doing is we're always needing the speed to get software deployed, because again, with 1 week of development cycle, you don't have time to deal with deployments. You can't spend 3 days trying to fix something with deployment, so we really had a need to get that under control, which is the reason why we kind of brought DevOps and started that practice within our own organization. And then again, as far as our cloud deployment, we have some stuff that's on-prem. The majority of stuff is either in Azure or AWS, and that's kind of our cloud infrastructure and what we're familiar with. All right, a little bit about DevOps. So again, you guys are here, so you're interested in DevOps. So who here has no experience with Agile development methodology? Everybody's pretty confident with that, okay? And the same thing with DevOps and DevOps, or DevSecOps. Everyone pretty confident with that? All right. So, really what DevOps means for me is basically the practices and the cultural values that are associated with getting software released as fast as possible. Again, in our case, our need to do 1 week sprints is what made us realize that we really needed DevOps within the organization. And really, DevOps is a marriage of development and operations, the ability of merging those two together. And then KEYSYS, again, the ability of us to have small customers to large enterprise customers, we really needed to get that out super fast. So that's why we actually started DevOps. So what is DevOps and what is it not? It's basically a cultural shift toward rapid and frequent releases. It's not a framework. So what DevOps means to me is going to be completely different than what it means to you or anybody else. Everybody has a different need depending on the organization. Again, if you are an organization that builds or has, in the medical field, it's going to be completely different than someone who is in e-commerce. It's going to be completely different than someone who may be in construction. So it's really what fits the mold for you. But the things that are always in common are basically a communication between project management, developers, and IT. The ability to kind of understand what each other is doing, and around that, you're going to basically put automation of software integration, testing, security, deployment, and infrastructure changes. And again, there's multiple different ways of doing that, but all of that kind of encompasses what I believe DevOps is. So here's a picture of the Toyota production line. This is kind of the best way that I usually like to describe agile methodology and why there's a need for DevOps. So with the Toyota production line, you have cars that are moving along in the production phase, and there's something called an anodyne cord that's basically like a Christmas tree that hangs from the top. And at any point, anyone in there, no matter what your job is, can pull that cord and everything shuts down in the factory. Anyone who's needed to help and assist in getting things moving again goes and helps that person out. Once that's done, they say, okay, everything's all clear. We're able to move along. So what that allows is that you know that because of the quality control and the ability to pull that cord, that any mistake can easily be rectified quickly so that things can get to the end of the production line in the same way. But where's the software production line? Where is ours? And DevOps and agile methodology is the same thing as a Toyota production line. Working at KEYSYS and having the ability to work in those groups 1 week sprints, at any point in the morning meeting, someone says, hey, I have a problem, something's going on, I need help. They pull that cord, whoever can help helps, and then things move forward. So that's kind of how we know that we're basically making good changes, no one's getting bogged down with things that are taking them too long, and in the end, we're delivering a quality product to customers. And those customers, again, can be external, internal, really doesn't matter who's using the software. So before DevOps, ultimately the whole goal of software is getting things from a developer into the hands of the end users. And again, the end user can be internal, it can be customer base, it doesn't matter. But what would happen is when developers would build code, they would send it over the fence, which is kind of the handoff, and say, let me get it into the QA department. That QA department would QA that software, they would throw it over the fence again and say, hey, everything looks good here, let's get it in the hands of IT operations. IT operations would do deployments of servers, whatever it takes to get that into production, and in the end, they would throw it over to the end user and say, here it is, everything's working. Now, if anything failed anywhere within that line, the thing that was an issue before is the fact that it would go back over the fence. There's a lot of finger pointing. You know, the end user would say, hey, what happened? Is it with deployment? Maybe not. Is it with the QA? Maybe they didn't test it as well. Or back to the developer, obviously, and just say, hey, there's a problem, right? But there's no consistent method of doing things. And even at the deployment end with IT operations, depending on who does that deployment, things may be different. So you may do it completely different than the other person, and that may be the cause of the problem. So that just became an issue in software development. So just to sum up the things that were wrong, I mean, again, developers worked locally. They usually would have databases locally to their computer. Anytime there was code merges, those code merges would be done independently. And then deployment of code, again, was done independently from different people. So what you end up needing to do is have long maintenance windows. So all of us who were in IT operations know, hey, we're going to shut the application down between 1 o'clock and 3 o'clock, or 1 a.m. and 3 a.m. To get this done. And the reason we needed those long maintenance windows was the need to roll back if there's ever an issue. Again, we're manually doing this stuff, we deploy it, it breaks, we need to go back and pull the backup, pull it out, and again, you can introduce new problems when you actually do a rollback. So there are a lot of issues that could occur with doing things that way. So again, with DevOps, what you're basically doing is first you're doing a cultural shift at the organization and say, hey, let's try to automate and make this as repeatable as possible and do things over again. Obviously, the first step of that is just source control, just the ability to have good source control, good merging strategy, good branching strategy to get code into a place where you know what's happening, you know what versions are out, which versions are released. And then from that, you can just start adding more tools to that. Obviously, you want your deployment tools like a Jenkins or a CodeShift or any of those. There are plenty of Testing tools where QA can say, hey, let me at least do a baseline test. Let me make sure that everything, at least from the baseline, works in the application. It works every single time there's a change, and then I can just test new features. I don't have to do regression testing and go through every single piece of the software. And then actually doing infrastructure deployments as well. Some applications, especially ones that are geo-distributed or have multiple things in the system, you have to actually build infrastructure. And again, doing it manually is a pain in the butt, but if you could do it and automate it, it makes things easier. And then when the last and most important step to me is monitoring of that application. Things like New Relic and Datadog, and actually seeing the insights of what's going on in your application, being able to set baseline changes and say, okay, well, after this deployment, what changed and why is it not running smoothly anymore? And using those tools is huge in pointing the finger, because I know if it worked Monday, there was a deployment on Tuesday, and then Wednesday we had customer issues, we can point back and say, hey, that deployment was the issue. So with DevOps, again, developers have the ability to collaborate. Automated code merging, code deployment, rollbacks, all being automated as much as you can. And then you're able to do negligible maintenance windows. I don't have to set a 2-hour maintenance window because I know that my plan will automatically build, deploy to production, and roll back if there's any issues. And if there are issues, not an issue. We can go back, it takes a couple minutes to get back, and it's not a big deal. It doesn't take hours to actually reconfigure things for the way that it used to be. All right, so in a perfect world, again, you want a CI/CD release pipeline to look something like this. I mean, again, developers are going to code. You're going to have your continuous integration, which is where you're going to do unit testing. Developers hate unit testing, but it's something that's super important to knowing that at least as a base, your application is functioning and works no matter what changes in that application. Integration, security, functionality testing. All of those are part of the continuous integration piece. And then from there, you go into delivery, which is deploying it to test. And one thing at KEYSYS that we do is we do a lot of deployments per day. Again, we have multiple customers, and we may have 20 active projects going on at one time. So one of the things that we need to do is be able to get that stuff deployed when the developer saves their code and get it into test so that everyone can kind of see those changes. Probably about 2009, I think at a conference, Flickr said they were doing 10 deployments a day. And back in 2009, that was just unheard of and crazy. People looked at them and said, you're killing IT operation, there's no way you're doing 10 deployments a day. And they were kind of on the forefront of really doing automation of their builds and deployments. Right now, it's not unheard of. I think Facebook does like 1,000 a day. It's not a big deal to deploy code because you're automating it and you don't have to have a crew of people to do those deployments. And then again, with the same thing, acceptance testing, we have a lot of UAT environments where customers need to get in. The ability to have it consistent with deploy, with testing and the UAT environment is important. And then finally getting it deployed out to production, which again, some things it makes sense for us to do that way. Other things we still actually do push button deployments where it's not automated. But all of that is in a perfect world of getting to that point. All right, so again, in sum, why implement DevOps? I think enhanced IT productivity is a big piece. The ability to get things out fast. Developers don't have to deal with worrying about deployments. Reduce application failures. Again, if you're doing things the same way every single time, at least you know that you have a baseline for getting things working. Increase revenues. The fact that you don't have to spend as much time, you don't have to have a huge IT department to deal with things because you're putting automation around a lot of pieces. And those times can be spent on things that are better for the organization, not just getting things deployed. Then faster feedback from customers. Again, from into a 1-week development cycle, we can go to customers and say, hey, what do you think about what we've done over the past week? They can say, you know what, I really hate that, or I really hate this. You can make changes immediately. You don't have to wait 3 months to deploy a product and then just be completely wrong. And then again, accelerated time to market. The reason that our companies are going to the DevOps model is the fact that you can accelerate that time to market. You can get things out a lot faster than you did before, which gives you an edge over competition. So, the game is changing. What has been introduced lately that's really changing things in the DevOps landscape is the cloud. Cloud is pretty prevalent now. A lot of people are going to it. There's AWS, and there's on-prem clouds. There are, again, there are AWS, Azure, Roku, all of which we've kind of worked with a little bit. But what actually changes with that is that what is interesting is that cloud isn't pushing, cloud isn't pushing DevOps, but DevOps is pushing cloud. The need for developers to get things out fast is making these app services actually do things a lot better to put automation around the things that they can do. So some of the benefits of doing DevOps in the cloud is having a centralized and standardized platform. So in the past, if you had a distributed system that was geo-distributed, say in 3 different countries across multiple data centers, the ability to actually set that up would be extremely difficult. You would have to have network engineers, you would have to have a team of server administrators. There was a lot involved in doing that. So right now, everything being API driven, I can geo-distribute an application with a couple API calls. So what's happening is that infrastructure is being exposed by API, which is allowing you to do things that you could never do before. And just really putting software automation around everything related to deployments. And then DevOps automation is becoming cloud-centric. Again, most public and private clouds actually have DevOps systematically built into their platform. They have the ability to do this, and again, everything is based on the ability to automate every single piece. So every new service that AWS comes out with, they're going to start off with the baseline API calls that you can make to it to do anything that you need to do in that. And then the governance. The fact that you aren't setting things up completely from scratch gives you the ability as a developer to have a little bit of governance on how to do things the correct way. Again, it's not the do-all, be-all, but at least it gives you a little bit of kind of how things are set up in the right way, doing it via this method versus doing it from scratch. And then cloud-based DevOps lessens the need to account for resources leverage. Again, before, if you had a VMware server and you were deploying 50 different apps to that VMware server, it was hard to say, okay, what's using what out of here resource-wise. But right now, you can actually have resources that are dedicated to something. You can have it in a billing group, and you can know, okay, well, this is why, or this application is using these resources, and this is the ROI that I'm getting off of that application. So, again, with KEYSYS internally, we make the migration to the cloud and move a lot of our stuff off-prem that we do. We still do hosting for some customers. Some we actually manage their cloud environment. So we have a lot of different setups just really depending on customers, and some customers do their own. But I kind of did this slide just to kind of show the thought process in migrating applications from a on-prem environment into the cloud, things around it. So kind of the first step here is the workload discovery. And workload discovery is just saying, hey, what workloads do I think would run better in a cloud environment? And the reasons could be a multitude. I need to be able to scale without actually buying hardware. Or I need the ability to lower my cost by moving to something that is not using a lot of resources. So actually finding out what workloads you think are suitable for the cloud. And then identify suitability. Is this really going to run better in the cloud? Or is there a problem with it? And again, all applications don't need to be on the cloud. I mean, that's obvious. There are things that are better on-prem, and there are some things that are better using multiple services across multiple clouds. It just really depends. And then from there, really mapping the cloud platform and services. Again, like AWS has about 200 different services that are available, and your way of doing it is completely different than someone else's. So just knowing those platforms, knowing what services they offer, how can I actually push it out there and leverage those systems is kind of the next step. And then, of course, actually doing the migration of the workload into the cloud. And then finally, the last step is just optimizing those workloads once they're in the cloud. So I want to give an example that actually popped up this week with the software that we dealt with that was API driven. And the original developer who did it put it on an Azure app service. So basically, an app service is an abstraction layer that's above the OS. So you don't have to manage the OS. Ultimately, it's just IIS that you can just manage sites on. So that's the way he did it. It has the ability to scale, but it's a manual process. And then finally, he was using Cosmos DB. Cosmos DB is a NoSQL database. The issue that we ran into is when he built that, we had 10 or 20 API calls an hour. It really wasn't a big deal. But as things started growing, we just added a new set of customers that immediately went to 100,000 API calls. Broke the app for two reasons. One being the fact that app services require manual scaling. We don't want that with 100,000 API calls every hour. And then the second piece that we had an issue with is that Cosmos DB was based on request units. So we were basically extending those request units. It was throttling us back. And for a high availability app, we can't do that. Obviously, that was the wrong solution to do there. So what we ended up doing was doing a migration of that this week into AWS. And with that, we set up a load balancer. We set up an auto-scale group to allow that application to scale as needed. We actually put it on a MySQL database, and it's running like a hoss now. And now I don't have to worry when it goes from 100,000 to 1 million requests because of the ability to actually scale the application out. And there are better ways of doing that as well. I mean, we could have easily used an API gateway with a Lambda service to do it, and then we're dealing with no servers and the ability to scale. So there are different ways to do things. There are plenty of services that are available. You just really have to find out what works best for what you're trying to do. All right. So we are at a security conference, so I want to talk a little bit about the security around AWS and the majority of cloud services. So there is a shared responsibility model, and this is actually an AWS slide that they give. So everything from the base layer as far as the data center, access to that data center, access to the servers, physically is the responsibility of AWS. Anything compute related is theirs. Storage, databases, their RDS service that they actually have the database service, and then the networking, the physical networking and access is all on their layer. Everything above that is 100% your responsibility. So data encryption, both client and server side, network traffic protection, operating system, you still have to harden your OS. That's no different than it was on-prem or in the cloud. Again, obviously your platform applications, and then identity and access management is 100% yours, which ultimately means that the customer content, customer data is 100% your responsibility to secure. So here I kind of go through a little bit of the options for your responsibilities and what that entails. So network configuration, again, 100% yours. Again, using AWS as an example, AWS has the ability to set up VPCs or basically private subnets. It'd be no different if you were setting it up in your own data center of doing that. And then within that, you can set up your security groups that will allow ingress, egress of rules. And what you allow is 100% up to you and easily able to be configured. OS firewalls are no different than if it was on-prem. Hardening of the OS is yours. Applications, obviously, you still want to do penetration testing, make sure that your application is secure, and then finally service configuration, and then authentication, account management, and authorization policies. 100% your responsibility. So there are a few security tools that are available with AWS. So one of them that I have up here is the identity and access management. That's one of the tools that I think is like the base of AWS that a lot of people don't leverage as much as they can. With AWS, they literally have granular controls down to every single resource that you use. Not only do you have that for a user that logs in, you also have that for services that you deploy. So if you deploy an instance or a virtual server, you can apply a policy to it and it'll actually have access based on that policy to other resources within AWS. So a lot of times when you look at it initially, you think it's kind of daunting to set up security in that method, but after a while you realize that it really isn't that difficult. It's just a JSON file that gives you access, and the best way to do it is to set up at the most restrictive first, and as you need to give more permission, you can give more permission to users as you go along there. So again, multi-factor authentication is built in. Security token service, key management service, so encrypting data at rest is something that's also available as part of AWS. They have directory services, basically AD, and then Trusted Advisor, again, another tool where they can basically go through and scan and say, okay, well, here's what we recommend you do to kind of secure things a little bit better. Again, it's not a super great tool, because again, a lot of this depends on how your software is developed, but it is something to at least give you a baseline to start. And there are plenty of third-party security tools as well. One that I've worked with before is ThreatStack, which basically is a configurable program you can run and installs resources, and it basically scans and goes through every single service, every single server that you have running, and kind of gives you an assessment of, hey, these are the things that you need to configure to comply with different, security policies. So definitely a great tool, and there's plenty of things that you can do there to kind of help out.